Our first section, I'll introduce the terminology that we use to describe each part of the rig, and that will help to recognise those terms in future parts of the explanation. So, control panel, for the drilling controls at the top, setup controls in the middle, speed adjustment controls. Engine control panel, which we'll come back to. Obviously engine, fuel tank, water pump, oil cooler, jockey wheel, oil cooler and fans, water pump, oil tank, rod racks, engine, battery, main hydraulic pump, jacks, rear jacks 1, 2, front jack 1. This part is the mast with the pulleys and chains and hydraulic cylinder inside the mast, combining to make what we call the hoist feed system, which pulls the carriage up and down the mast, and the carriage carries the rotary head with its hydraulic motors and air swivel. Below the rotary head is the drive adapter to connect to the drill rods and the hammer, and that passes through the working table and guide. To move the trailer, the height of the towing eye needs to be brought to the height of the towing vehicle. At the moment it's too high, but we can alter the height of the towing eye by moving the weight distribution on the trailer. So if we move the rotary head higher up the mast, it will put more weight to the front and move the trailer downwards. Or if we move the rotary head towards the back, similarly it will move the trailer with a higher position for the tow eye. The tow hitch is now at the correct height. We can put the jockey wheel down by undoing the clamp, dropping it down, and then altering the height with the winder, which again will have some effect on the height of the tow hitch, and it also leaves the trailer in a safe position so that it won't tip if somebody comes and starts jumping up and down on it. Once the tow bar is connected to the towing vehicle, then we'll lift the the jockey wheel up, so the vehicle is now ready to move. Engine controls. We have a start switch here on the key. The first click is ignition on, shown by the red light, and the next turn starts the starter motor. the red light will go out after the engine starts and sufficient revs have been reached to produce a charging current for the battery. This ammeter gauge here shows the amps of the alternator when charging. This switch is for the electric fans of the oil cooler. The engine throttle has a vernier control, so you can twist it, open it to increase speed and leave it at the desired engine speed. To shut down the engine, you can just again rotate it or press the button on the top and push it down quickly to close it. The engine stop is only on this red lever on the side of the engine. It is not stopped by the ignition switch, and it's important to remember to turn the ignition switch off after the engine has been mechanically stopped. So I'll now just run through that starting procedure. I'm switching on the ignition, red light. I give it another turn for the starting. Turn off the ignition. We're now going to go through what we call the setup procedure, which is setting the rig up ready for working. We'll assume it's disconnected from the towing vehicle and we're in the correct position as far as drilling is concerned. First of all, we start the engine, and then we will go through the procedure for adjusting the 3 jacks, 2 at the rear, 1 at the front, to give a level position as indicated by a T-shaped level gauge here to the side of the control panel. That ensures that the machine is level for drilling irrespective of any other factor. Once we have the 3 jacks down and the machine levelled, we will then raise the mast and lock it into position at the front of the machine. All the controls are spring to and return to neutral in either direction, so that if you're doing something and there's a problem, feel there's a problem, you can just let go, the lever will spring to neutral and the motion will stop and be locked in position by lock valves which are adjacent to the jacks. You can see that the labels for all controls are marked with both the name in English and with a little drawing that illustrates the function, and that little drawing should be understandable by anybody. So we'll just now go through those 4 functions. Starting the engine, we'll set the speed, we'll put the jacks down, level the machine, and then we'll lift the mast. When lifting the mast, do be careful that there's nothing loose been left on the top of it, for travelling or by a maintenance mechanic, because it will fall when we raise the mast. The other thing to do is to be very careful that the hoses on the other side do not get snagged as we lift the mast up. And this is the responsibility of the driller, or he can have his second man standing around the other side and keeping an eye on the hoses as the mast is raised. So we'll now start the engine. Behind the mast there is a screw jack which fits into a bracket on the chassis. This enables us to mechanically tie the mast into the machine and takes any wear off both the pins and the cylinders. So when we get to this stage of raising the mast, we need to stop, make sure the screw is in a position where it's up, out of the way, but once we get the mast in tight against the back of the chassis, we can drop the screw and tighten it up. The airline lubricator has a purpose of feeding hammer oil into the airstream that goes down the whole hammer, with the whole purpose of keeping it lubricated and increasing its life. The airline lubricator is driven by air, taking a small bleed of air off the main air pipeline where it's fed in from the air compressor. You may need to change the adapter here to suit the hose that you provide from your compressor. But once the air is flowing, a small bleed pipe feeds into the airline lubricator and drives the air pump. For demonstration purposes only, we've just put a small airline into the system instead of the pipe from the airline that I've just indicated. The air, when it comes through, can have the pressure regulated by this valve here on the top, and the pressure gauge will tell us whether we're working at 5 bar, 10 bar, 15 bar. The normal pressure should be about 8 to 9 bar, but it's the lower you can make it, the longer lasting will be the hammer, and it reduces energy and oil consumption. So we'll increase this up to about it's about 8.5 bar now, and I'll lock that off. The air then passes through a water trap, and this needs opening once a day to let the water drain out of this trap here. Again, it all helps to prolong the life of your hammer. After passing through the air trap, the air goes into this unit here, which is an air-driven pump, and it pulls oil out of the reservoir and pumps it down this pipe through a speed control valve, and thence to the pipework and the hose that runs the air line up into the swivel, through the rotary head and down to the hammer. So as long as the air system is working, oil will be pumped into the airline and will lubricate the hammer. Switching off the main valve from the compressor will also shut off this unit as well. But otherwise, whenever the air tap is open, air is fed from the compressor, then this unit will work. And the speed control valve controls the speed at which it's pumping. I hope you can hear that noise.
Yeah.
The required pulse should be about once every 45 seconds, which will then feed about 1.5 litres of oil per hour into the system. But depending what pressure compressor you're using, you may need to adjust that, and I recommend you read the handbook on the lubricator system to fully understand what flows and pressures you should be working at according to your system requirements. But main points are: make sure the reservoir is full. There's a level gauge here on the side. The oil at the moment is filled to about there. Check the pressure setting on the gauge, and then open up the speed control valve to get the required flow. It doesn't matter if you use too much oil, it's obviously more expensive, but there is no side effects that you need to worry about. The main important part is just to get that pulse of oil going into the airline every few seconds to keep the hammer lubricated. The water pump is hydraulically driven from a supply off the main pump, and we'll look at the control in a moment. The output from the water pump feeds into the main airline going up to the rotary head and down through the drill rods to the hammer and into the hole. The water pump would be used for dust suppression, but if you are using the water pump, we'd recommend increasing the amount of oil that's fed into the system to keep the hammer lubricated. The hose which provides the suction and supply to the pump is a 1-inch BSP hose. It has on the end a strainer to stop debris being sucked into the pump, sand and so on, and it also has a non-return valve which allows water to pass through this way to the pump but not to come back out the other way, so it would only go through that way. So to prime the system to start with, disconnect the hose, fill it with water, reconnect, and then the pump will prime itself automatically when you start up. The non-return valve will stop the water running away and hold it in the hose, so that once you've primed the pump on site or at one particular hole, you should not need to prime it again. This valve will hold the water in the hose after use, and just means that you should only need to start it on, set your speed, and not worry about having to prime the system. The control for the water pump is here on the main control panel, separate valve to everything else, clearly identified as pump. It switches down and holds in the down on position and will remain there until it's moved back to neutral and the pump will stop. So down for on, holds in position, back to neutral to stop. That selects the pump. It provides a flow of hydraulic oil to the hydraulic motor that drives the pump. In addition to the selector lever, there is a speed control knob on the top of the valve. Don't get confused with the relief valve, which is hexagon shaped and painted, and you need not adjust that. This is a speed control knob which will vary the speed of the pump and supply more or less water into the air system and down the hole to suppress dust. Drilling controls. There are two valves that control the drilling. The top one is rotation, which is down for drilling direction, neutral, and up for reverse direction. The lever detents into position, so you don't have to hold it down all the time for rotation. It will hold down until it is consciously moved back to neutral. The rotation speed is strictly controlled by the speed of the engine, therefore the speed of the hydraulic pump and the amount of oil going through the system. In conjunction with rotation, we have a feed lever. Feed is when we're pushing the, drilling the drill rod, the hammer into the ground. Hoist is when we're going upwards. So we have two ranges of speed on the feed. We have a slow feed, which again detents into position, neutral and slow hoist, and we have a fast feed. Slow feed has two additional fine controls. We have a feed speed, which will control the rate of descent of the rotary head. Normally when you're hammering, you'll have that pretty well closed. So rotate clockwise to show to slow down the rate of feeding in to what's comfortable and acceptable. But we can also control the feed pressure, and the feed pressure is the amount of downforce being put on the drill string by the rotary head. The feed pressure is shown on one of the two pressure gauges, and normally for hammering you don't want any more than about 500 psi. More than that, although it will go up to 2500, really let the hammer do the work, have a light feed on, and let the hammer do the work. So, slow feed lever, down for feeding in, control the speed, anti-clockwise to increase, clockwise to decrease the feed speed. Pressure, increase the feed pressure by screwing it in, decrease by screwing it out, and the pressure is shown on the gauge. If you do want to flush the hole, just lift the hoist control lever, and when you go back in again, if you want to go in quickly without having to change the settings you have down here, just move this valve across and that will give you the same down feed speed as up feed speed. So that's giving you fast feed, bypassing these slow controls down here. Normally for drilling that will always be round the back. So we have rotation and down feed, and they both go in the same direction. That will be giving us rotation, down feed, and then we can control, our hands are free to control the speed and the pressure. We've now drilled in the drill string as far as we can go before we need to add an extension rod. The way we do that is to put a drill rod spanner across the spanner flats and resting on the top of the guide. We'll then rotate the drill anti-clockwise, and the spanner will hit hard against the side of the mast, and we'll be able to unscrew this part, which is the drive adapter, which is fixed to the rotary head. Take the rotary head up the mast. We'll then lift an extra drill rod on using the strap connected underneath the head. We can lift it by hand, but let the machine do the work. So we can lift it by hand, slide it into position underneath the rotary head and screw it on top and bottom, then we'll carry on drilling. As far as routine maintenance is concerned, always check the hydraulic oil level on a daily basis. It should show near the top of the window. There should be a small amount of airspace in the tank above the oil level to allow for expansion in the heat. So just make sure that the oil level is just showing in the top of the window. Check the fuel level twice a day. It's important to make sure you don't run out because these engines don't bleed very easily. Fuel level on a daily basis. Engine oil level on a daily basis. Check up to the mark. A little bit of oil on things like throttle adjusters, rotary valves, because they will dry in the sun and the dust, and a little bit of oil will keep them nice and free for adjustment. There are then only 4 grease points on the machine. They are, the most important one is on the swivel unit on top of the rotary head. That should be greased at least once a day. It's rotating all the time, it's taking a lot of pressure, really should be greased at least once per day. The other places are the bearings in the sheaves of the chain. There's one at the bottom of the mast, one here in the middle of the mast on the sheaves that go up and down, and another one right at the very top of the mast. Just one squirt of grease once per week should be quite sufficient. It also pays to keep the chains lubricated. This may make for some dripping of oil onto the mast and make it look dirty and dust stick to it, but it's well worth putting some old engine oil or of any sort of quality onto the chain to prevent them going stiff, as they will do in the hot, sandy temperature. But otherwise, a little bit of oil will keep them in tip-top condition and they should last for a long time. Changing or adding a bit to the hammer is quite simple. Unscrew the chuck at the bottom of the hammer. Slide it over the bit. Inside the hammer there is a pair of split collars which go over the end of the bit to retain it within the chuck. They're held together with an elastic O-ring just to make it easier when assembling. Keep them together. So there they are in position on the end of the bit. Now all we have to do is to slide them all in together.